So today's lesson is going to be on subscripts, and we're going to be on page 38 of your packets. So the objective for today is I will be able to read and translate variables and subscripts to create math expressions. The learner profile for today is to be a thinker by brainstorming reasonable outcomes for math expressions. Subscripts are used in chemistry, physics, and mathematics, and even computer programming and the stock market exchange. Subscripts are used to differentiate items that may appear to be similar or are related. Below is an example of items at Burger King. Identify the subscripts to differentiate items that may appear to be similar. So if you look at the Whopper here, the Whopper has a variable W, and a chicken sandwich has a variable C, and there would be no confusion between the two. But once you get into the French fries, there's 3 different types of fries, and there's 3 Fs, and we wouldn't be able to tell which one is which. So this is your variable here, which is your big letter. This here is what we know as an exponent. And here is a subscript. Okay, we don't actually do any math with a subscript. It's literally just a label. Okay, and subscripts can be letters and they can also be numbers. All right, so the first thing I'm going to ask you to do is take your menu items and create subscripts for any of the items where you might not be able to tell if it didn't have a subscript. All right, so let's check your work. Most probably you had the same subscripts as I would have. Small, medium, large, small, medium, and large. Okay, so we're actually going to use these subscripts to answer a few questions on your next page, or it might actually be right below. So part 1, order up. I'm going to bring our menu items, make them a little bit small for me here. All right, write in words the meaning of the following expression using the table. So you're really just going to look at what's here, and I'll do the first one with you. So you are going to order 5 Whoppers, two small fries, and 3 large drinks. Okay? So I want you to go through and complete the order. So what did each family order? So checking your work, you should have figured out that there's something weird in the menu items. And so here in the second one, there's actually nothing up there for M's. And so what it means is they ordered 2 things, 4 items total, but they're not on the menu that we're looking at. And then you end up having that same thing happen again with this WC. So we actually don't know what a WC is because it's not in our menu. Now we can make some assumptions. Maybe it's a Whopper with cheese. But I wanted just to identify the fact that sometimes, like, you really do need to look at the variable and make sure it's something from your list. And in this case, we really could simplify this. There were 6 Whoppers, 2 more Whoppers, 8 more Whoppers, and that's actually 16 Whoppers plus. And I'm literally just going to ignore this for now, just because we don't know what the item is. And I wanted to show you that when the items are the same, we can add them together. So together we have 16 Whoppers. The same way we would add variables. If I had 6 W's and 2 more W's and 8 more W's, I would have 16 W's. When we talk about Whoppers, it does make a little bit more sense. I'm adding the 6 Whoppers, the 2 Whoppers, and the 8 Whoppers. And what I can't add is this guy here. We don't know exactly what it is. Okay? So then on your next page, we have part 2 on page 39. So here you're really going through and you're double checking if things make sense. And so As you read them, you're going to identify, is this something that we can do? So let's look at number 1. W is the number of Whoppers. So we're taking the number of Whoppers and multiplying it by the price of a Whopper. So does this make sense? Well, yeah, it gives us the total cost for your Whopper purchase. Okay, so you want to go through each of them and identify what the expression actually means and if it makes sense or not. So this first one, yes, it makes sense. And my reason why it makes sense is because I identified what it is that they're actually doing there. Okay, so go ahead and finish this page. So let's look at the two that do not make sense. So number 1 is the one we did together. Number 2, you're multiplying the price of a drink with the number of fries. And this doesn't make sense because when you multiply the number by the price, you do get a total cost, but in this case, you're not multiplying your fries by the cost of fries, if that makes sense. Okay? So that's the reason number 2 doesn't make sense. Number 4 also doesn't make sense because if you take the price of a drink and add it to a number of drinks, well, you're literally adding money and just a number. So it doesn't make sense. And if this might help a little bit, if the cost for a drink is $2 and you decide to order 5 drinks, you end up with a number 7, but it doesn't make sense. So if your cost of a drink is $2 and the number of drinks you got was 5 drinks, you really should be paying $10. And so this 7 doesn't make sense because you're mixing units. Units meaning the labels for the numbers. So you're mixing dollars with just a number. All right. So now, in order up, you're writing an expression for the following description using the table variables. So you're just going the other way. And so you want to create Juan's order based off of what's here, and you want to figure out the total items that Juan orders. Okay? So his cost would have to be, everything that you're adding would have to be a price. And for the total items, every single thing you're adding has to be the number of. So we can't mix the variables with a subscript of P, which stands for price, with the regular variables themselves. All right. And then extra symbols practice, which is page 41. That's what you're going to work on. And then I'm going to have an answer key available back on your agenda to check your answers.